Welcome to this video on radicals. Radicals is a major topic. There's quite a bit to talk about, so this will definitely spill over into multiple videos. We'll just fill up one of our 15-minute time slots and then continue where we left off as necessary. Alright, so to begin with discussion of radicals, I want to tie it into exponents because there's something in the exponents chapter that we didn't cover in the exponent videos. I wanted to save it when we talked about radicals. Okay, so first of all, to review what an exponent is, if I have a positive exponent like 9 squared, that just means two 9s multiplied together, which we know is 81. Okay? If I have a negative exponent like 9 to the negative 9, we know that we can move that to the other side of a fraction and it becomes a positive exponent. So that's 1 over 9 squared, which is the same as 1 over 81, right? So we know what positive exponents mean, we know what negative exponents mean, but what would 9 to the 1/2 of a fractional exponent mean? Okay, to investigate that, I'm going to write two of those next to each other and then use our exponent property to see what has to happen. Let's say I have 9 to the 1/2 multiplied by another 9 to the 1/2. Hopefully you'll agree that that's the same as 9 to the 1/2 plus 1/2 because we would add the exponents. And that means 9 to the 1, which is just 9. So this whole thing has to equal 9. And what that means is each 9 to the 1/2 is whatever would multiply by itself to give 9. And what is that? Well, that's the square root of 9, right? So what that means is that 9 to the 1/2 is equivalent to the square root of 9. Right? And that in general is what a fractional exponent means. It means a radical or a root, right? 9 to the 1/2 power is the same as the square root of 9. And that little 2 there indicates that we multiply two numbers together to give a 9. Now the square root of 9 actually is a 3. So that means 9 to the 1/2 is equal to 3. Okay? Does that happen in general? Let's try 1/3. What is 8 to the 1/3 power? Well, 8 to the 1/3 power, if I multiplied 3 of those together, right, I would have 8 to the 1/3 plus 1/3 plus 1/3, which is 8 to the 1, which is equal to 8. And so that means each of these 8 to the 1/3 is the cube root of 8, right? It's the number that multiplies by itself 3 times to get 8, right? And so fractional exponent does mean a root. Raising to the 1/3 power means the cube root of the number, right? So in general, right, taking anything to the 1 over n power is equal to the nth root of a, right? For example, 64 to the 1/2, you could write that as the square root of 64. Or if you have 64 to the 1/3, that's the cube root of 64. So there's two ways to write each of these expressions. You could write it in its radical form, or you can write it in its exponential form, right? And one of the things we're going to practice is just going back and forth between the two forms. Okay, so that's a key idea. What about a fraction with a non-1 numerator, something like 8 to the 2/3 instead of 8 to the 1/3? Well, we can also use this property, that if you have 8, I could write this as 1/3 and then that whole thing squared, because if you have an exponent raised to an exponent, you multiply. 1/3 times 2 is 2/3. Well, the inside of this is equal to the cube root of 8 we found out, and squared. So what is that equal to? 8 to the 2/3 is equal to the third root of 8, and then the whole thing is squared. So what I want you to realize is that the number on the bottom of the fraction is the root that we take, right? And the number on the top of the fraction is what we do to the entire result. So you take the cube root of 8, but then when you're done, you square it. And actually, this is another key point, too. What is that? Let's actually evaluate what that's equal to. What is the cube root of 8 squared? Well, the cube root of 8 is 2, right? 2 times 2 times 2 is 8. And if I square that number, I get a 4. So I want you to see something else, too. If I were to write it this way, the cube root of 8, but instead of taking the cube root first and then squaring it, what if I squared the 8 first and then took the cube root? Well, that would be the cube root of 64, and the number that multiplies by itself 3 times to give me 64 is also 4. So another way to write 8 to the 2/3 is the cube root of 8 squared. In other words, you know, the bottom of the fraction, the 3 here, is the root, but that squared can either happen to the entire result, or you can square the 8 first before taking the cube root of it. Okay? So this is kind of the property right here, if you want to look at that. right? 8 to the 2/3 you can either write as the cube root of 8 and then square that whole thing, or the cube root of 8 squared. Okay, so here that's written out as a property here. A to the m over n power is either the nth root of a to the m or the nth root of a quantity to the m power. Okay, all right. So what I'd like to do then is just practice. Let's just practice going from exponential to radical form and back. Okay, so pause the video, try each of these problems, and see what you get. I think you'll find that when you unpause, you can check your answers and see if, when you get this. So radicals and exponents related to radicals just require a lot of practice. So if at first it seems mysterious, keep at it, and you'll get there eventually. Okay, so welcome back after trying this. Here's what you should have gotten. Square root of 3, that's the second root of 3, so that's just 3 to the 1/2 power. 3 to the 1/2 power. Okay, this whole thing is the second root, the square root of 3x to the y to the 5th power. So you take that 3xy and you raise it to the 5/2. That's all there is to that. Going the other direction, right, you have a negative 27, right, and you can either think of that as squaring it first and then taking the cube root, or you can think of it as taking the cube root of negative 27 and then squaring that result. Either one of those is correct. So those are two ways to write the answer here. Okay, another one. Pause the video, try all three, unpause it. Okay, so what do we got here? First of all, I'm going to take advantage of the fact that I could change this to a positive 4/3 power by taking the reciprocal. And then I'm going to note that each of these numbers, 64 and 125, appear to have cube roots, so I'm going to split that 4/3 into a 1/3 power, and then that I'm going to take to the 4th power separately. So I have 1/3 times 4. So that I can write this as 64 to the 1/3 over 125 to the 1/3, and all of that to the 4th power. And taking something to the 1/3 power is the same as writing as radicals. I'm just trying to write this as radicals here, so I'm not going to solve it. I just want to try to write it as radicals. This is the cube root of 64 over the cube root of 125 to the 4th. So you could write it like that, or if you wanted to, you could even combine it in one further step. So I'll do one more. I'll just have one big cube root of 64 over 125 and have all that to the 4th power. And of course, you could also do the 4th inside if you like. We're not actually solving it here. We're not simplifying. We're just writing it in the other format. Okay, the second one, let's see. I've got a 2, I've got an x, and then I've got this, which is cubed and 4th root. Now, how could I combine that further? Maybe I should use another color here just so it doesn't get too crazy looking. I've got an x and x to the 3/4. Well, I'm going to add that, so eventually I need a common denominator. How about if I write this x to the 1 as x to the 4/4, so that then when I add these, I get 2x to the 4/4 plus 3/4. That's 2x to the 7/4. So that would write it using exponents instead of radical sign. Okay, and then let's do the next one. I've got y's and z's. They don't combine in any way, but since they're in exponent form, let's write them as radicals. 2, and then I'm going to have the 4th root of y cubed, and then I'm going to have the 4th root of z to the 1st, which I could combine if I want to. I could combine that into one root that has z y cubed, something like that, or y cubed z. That'd probably be the best way to write it. Okay. 2, 4th root of z times y cubed. Okay, same thing. Let's write radicals as exponents and exponents as radicals. This time we're going more from exponents to radicals. Let's see, a to the negative 3/2 power. Well, that's going to be, let's see, we can think of that as, well, it's the second root of a to the negative 3, which you could write that, let's see, I probably want to get rid of all of those, right? So I should probably write that as square root of 1 over a cubed. That'd be one way to write it, right? Yeah, I'd probably leave it like that. You can't completely get rid of exponents here, right? Because a cubed is a cubed. Okay, what about this? We have 2x minus 1 to the 4/3 and 2x minus 1 to the negative 1/3. Well, since these bases are the same, I think I could take that and add the exponents, right? And so that's going to be 2x minus 3 to the 3/3, which is 2x minus 3 to the 1. So this whole thing just simplifies to 2x minus 1. Right? What about this one over here? We have x minus 1 over x minus 1 to the negative 1/2. Well, that's the same as x minus 1 times x minus 1 to the positive 1/2. But raising something to the positive 1/2 is the same root as taking the square root. So I think that might be the best way to write it if you need to have it in form of using radicals. Okay. Let's continue with some more properties here, and like I said, we're going to run out of time at some point, but we'll just pick up where we left off in the other part. Okay, this is actually a major property of radicals, that you can take two numbers that are multiplied under a radical and separate those into two separate square roots. So let me give you an example here with the format, right? If you have the nth root of a times b, you can write that as the nth root of a times the nth root of b. And that works whether the numbers are multiplied or divided. If you have the nth root of a over b, then that's the nth root of a divided by the nth root of b, provided that b isn't 0. So it just means that you can separate things that are multiplied together or divided into separate radicals. And it's important that this works for multiply or divide, not for add or subtract. This is only for multiplying or dividing. Okay, but we can use this to do what we call simplifying, which we're going to go into in the next few screens here. This square root of 200 over here can be written as the square root of 100 times 2, which means I can split it into the square root of 100 times the square root of 2, but the square root of 100 is the same as 10. So that can be written as 10 square root of 2. So we can use this property when we try to simplify radicals. Right? I can go the other direction. I could say if I have the square root of 3 times the square root of 12, that's the same as the square root of 3 times 12, which is the square root of 36, which is just 6. So sometimes it helps us simplify if we combine. Or let's say I have the fourth root of 27 over the fourth root of 9. Well, there is no fourth root for 27. Well, there is, but it's not an integer, right? There's no fourth root of 9 that's an integer. But what I could do is say this is the fourth root of 27 divided by 9, right? I can recombine that into one division, and then 27 divided by 9 is 3, so that does simplify to the fourth root of 3, okay? So you could do things like that using this property. Okay, let's see. More properties. Here's another one. This property says that if you have the mth root of the nth root of a, then that's equal to the m times n root of a. Okay, it's actually easier to see this with a number, I think. So this is the cube root of the square root of 10. You know, one way I like to think of it is you can, if you're confused by this notation, you can convert this to exponent form, right? This is the inside of this is 10 to the 1/2 power, and then you're taking that to the cube root, right? So you're raising that to the 1/3 power, right? And that means you can multiply the two. That's why this is the same as the 1/2 times 1/3, or 10 to the 1/6 power. That's the reason why this is just the 6th root of 10, right? So if it's confusing, you could go to exponent notation. Sometimes that's easier. But anyway, what this means is that the 3rd root of the 2nd root of 10 is the same as the 6th root of 10. Okay? All right. Let's see. Let's see. Matching exponents and roots of radicals, they undo each other. So they're inverse operations. You know, I know when we solve equations later, we're going to take advantage of the fact that square roots and squaring are inverse operations. They cancel each other's effects out. The same as multiplying cancels division, adding cancels subtraction, things like that. Okay, but there is a kind of a caveat for this. So I think we'll probably stop this video and pick this up. This is a major topic, so we'll go on to the next part before we actually get into that in more detail.